So as of the moment, the biggest hydropower or hydroelectric power stations in the world is the Three Gorges Dam in China, which has a capacity of around 22.5 gigawatts of electrical energy generation. So this is part of along the Yangtze River in China. And also in our own country in Australia, we have the Snowy 2.0, the snowy mountains in near the outskirts of Victoria, New South Wales, and South Australia. So the construction of this pump storage in snowy mountains is able to add about 2,000 megawatts of energy generation and also around 175 hours of energy storage. So this is one of the ways to ensure that when there is a demand or if there are losses or there are droughts in the wind energy generation or solar energy generation, then we have a pump hydro storage that can provide the needed electricity at such peak time. Of course, when we talk about hydropower, we need or an equipment that would enable the transition or the generation of electricity coming from the flowing water. And in this way, we need a turbine for that, a water turbine. So for a water turbine, there are two kinds that we need for this kind of turbine. We have the impulse type and the reaction type of turbine. So we can see from here a simple schematic of how the turbine looks like. So we have a propeller type of turbine blades here, and the water is coming from the dams. So through the penstock, and the penstock like a pipe, a very long pipe that enables the flow of water and go towards the propeller type of turbine. So this one turns now. So once it's turning, then the shaft that is connected here will also turn the rotor of the generator. And so we have a stator here, as we know when the generator turns, and so it also generates electricity. So this is how it works. For this type is like a reaction type of turbine, and another type is an impulse type. And so in the next slide, we'll try to discuss about the various types of turbine and their applications to various types of head. Okay, how much the potential is needed for enable is to properly work. So as mentioned, there are two kinds of this turbine. The impulse turbines are and the reaction turbines. So the main difference between the two in terms of design is if you look at the two designs here, the reaction turbines are turbines that are fully immersed in water. So it means all parts of the turbine are touching the water. So they are immersed. So they are submerged in water. While on the other side, the impulse turbine is that only the part where the blades that is touching the jet of the water is touching the water. The other sides are touching the air. So it's not fully immersed type. So there's a jet of water that is impinging to the cups of the turbine blades or the turbine blades here so that it will turn and generate electricity as shown in this animation here, a simple animation. So when you look at the Pelton wheel as an example of impulse turbine, so we can also see here from the impulse turbine configuration. So there's a nozzle here that impinges a very high pressure water, which is tangential to the cups here. So the cups are designed to really be able to capture all of that water velocity or the stream. And so we have a fixed nozzle that impinges on the blades of the turbine, and so now it's turning the turbine to power the generator. So in this case, we have also a pressure, a high pressure that impinges towards the blade, and so the pressure suddenly drops because of that impingement, and so the stream velocity also this it's a very high stream velocity once it goes towards the blades. In the same way, in the other way, the reaction turbine is fully submerged. So in this case, the other one is not fully submerged, right? So this part here is touching the air, while in the reaction turbine, the whole of the system has water in it. and so the water will go towards the rotation of that blade and out of the system. So if you compare these two kinds here, this is as a example of Francis turbine. So we have two kinds of reaction turbine, the Francis turbine and the Kaplan turbine. So the main difference, if you look at the design, is the Kaplan turbine is like a wind turbine. So it's a propeller type. But this part here, the Francis turbine, is more of a spiral annulus. So it means that coming from the penstock here, it goes towards a sort of round thing, and then it will go radially into the turbine to rotate that blade, the turbine blades, and then go out into the other side here. And so this turning here is more of it's going radially here, and then their axial part as well that goes out. So in terms of its use, as I mentioned before, these reaction turbines are used for lower head and larger flow rate of situations. And so for run-of-the-river flows, usually we use these reaction turbines because the run-of-the-river are quite low in head. For large head, we can use this one, but in terms of using in dams, most of the dams are using Francis turbine type. All right, so this type has been used in many of the dams around the world for their power generation. So, okay, so this is an example here. It's now turning. So we can also show the next slide here, the various choices or the different types of the turbine depending on the head and the type of the turbine. So these two are here, the Kaplan and Francis type, are all reaction turbines. As I mentioned, they are low head systems. So the low head means from 2 to 40 for Kaplan, and Francis is 10 to 350 meters. So this is meters here, and it can generate up to 800, even 1,000 megawatts of electricity. For impulse, the Pelton type, this is an impulse type turbine, which is a Pelton type. So as you can see, like a bucket type of blades that can capture the impinging jet of or high pressure jet of the water. And so this is the type here. So if you look at this figure here, you can see that the various types at various capacity, the flow rate, the head, as well as the production capacity. So Pelton turbine is high head systems, but low flow rate. So we can generate up to 10 megawatts as well. But even for this one is the high head system, we can generate much lower, I mean, of megawatts. For Francis turbine, we have low head, so low head here, and the Kaplan is much lower head, so about high volume flow rate. So usually for run-of-the-river systems, we can have we use normally the Kaplan type of turbine because they are the propeller type. So they can be in terms of this is a form of Kaplan type, and this is a Francis. So you can the Francis turbine. If you look at here, the water is coming from the side and goes out as an axial direction here. So from radially, it's turning this system here, and then goes out radially. So if you have a dam coming from here, the water from the penstock going down, and then turning this part to turn the generator. In the other way, the reaction turbine of Kaplan type is more of an eggshell, just like a wind turbine as we see. The wind turbine before we have a wind to rotate this one, so the wind has to go eggshell as well, or 90 degrees of the turbine blades, right? So this is for high flow rate and low head systems. Okay, so please remember the different types of turbine that are used for generating power by hydroelectric power station.